Hello everyone. In this video, we'll be talking about Fibonacci series and how we can find the nth number in a Fibonacci series using recursion. So in the previous video, I have explained you how recursion works and with an example of finding the sum of n numbers. So if you want a refresher, you can go back to that video and then come back to this Fibonacci video. Okay, so let's start with defining what is a Fibonacci series or how do we write a Fibonacci series. So Fibonacci series is nothing but writing 0, 1, and then the third digit is nothing but the sum of the last two digits, that is 1. Similarly, the fourth digit will be the sum of third and second digit, that is 2, and it goes on. 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, and so on. Alright, this is nothing but we can represent it in this form. Considering this is nth digit, right? Considering this is n minus 1th digit, this is n minus 2th digit. Okay. So if you want f of n, right? If you want this value is nothing but f of n minus 1 plus f of n minus 2. This is nothing but the basis of our recursive formula for this particular problem. Okay. Let's try to solve this in the form of code. All right. Let's call it Fibo of n, which means here n is nothing but the nth digit that we're trying to calculate, nth place. So if you consider this as 0, 1, 2, 3, 4, 5. If you want n equals to 5, the value is 5. If you want n equals to 4, the value is 3. Similarly, if n equals to 6, the value will be 8. Okay. So from our previous video, we know that there are three basic conditions in a recursive function. The first condition is the exit condition. Okay. The second is the recursive call. And the third is the calculation. Here, what would be the exit condition, right? So here we know that if we want this particular value or if we want this particular value, so whenever n value is 0 or whenever n value is 1, we know that these are fixed values. It is always going to be 0 and this is always going to be 1, right? Because these both values are written by default, and from the third value we are starting the calculation of the further values. What I mean to say is, if we speak in terms of static and dynamic, the first two digits will always be static and the rest of the digits can be dynamically calculated, right? So using these static digits, we will define our exit condition. So our exit condition will essentially be if n value is equal to 0, right? Then we would return 0. Similarly, the next condition will be if n value equals to 1, then we would return 1. Essentially, if we are trying to calculate nth place here, right? So if n value is 0, the value we return is 0. If n value is 1, the value we return is 1. Else, meaning if it is anything other than 0 and 1, then we will have to dynamically calculate it. And this is how we do it. So our exit condition is defined. This is nothing but our exit condition. Okay. The next thing that we need to do is the recursive call. So here, as you can see, the function that we defined here, this will consist of two recursive calls. We'll not just be calling f of n minus 1, but also f of n minus 2. So we can write it like this. Recursive call 1 will be equal to Fibo of n minus 1, and recursive call 2 will be equal to Fibo of n minus 2. These both are our recursive call. Then the last part, that is calculation. This is nothing but this, which is recursive value of 1 plus recursive value of 2, and that is what we would return here. Okay, let me write it down in proper text and then I'll explain it once again. All right, Okay, so our function is fibo of n. The first thing that we do is we check if n is 0, then we would return 0. The second thing we do is if n is 1, then we would return 1. And then we would start our recursive calls. So the first recursive call will be calling fibo of n minus 1. The second recursive call will be calling fibo of n minus 2. And then we would do our third step in the recursive call, that is calculation, which is recursive 1 plus recursive 2, and that is what we return. Okay, all right. Now let us take an example so that it is much better to understand. Let's try to find, let's say we are trying to find the fifth digit in the recursive series. Sorry, I mean in the Fibonacci series. Let me write down the series again here so that it is easier to identify. Oops, sorry, this should be 1, this should be 2, 3, 5, 8, and so on. Okay, seeing this as n, 0, 1, 2, 3, 4, 5, 6, and so on. Okay. Okay, now let us try to understand this problem with the help of an example. Let us consider we are trying to calculate Fibonacci of 4. N is equal to 4. It will come to the first line, n is 0 false, second line n is 1 false again, then it comes to this part, which is REC of 1, that is recursion of 1 is equal to Fibonacci of n minus 1, that is 4 minus 1, which is 3. Now let's see how we would calculate Fibonacci of 3. Here again we do the two checks, n is 0, n is 1 false, then it comes to this REC of 1 equals Fibonacci of n minus 1, that is 2. Okay, so now we have to see how we calculate Fibonacci of 2. Let's do that here. Again, same condition, n is 0, n is 1 false. We come down to REC of 1. So that is nothing but recursion of 1 equals Fibonacci of 1. Okay, now that we reached Fibonacci of 1, so Fibo of 1 will be calculated like this. If n is 0, false. If n is 1, then we are going to return 1. Right? So now we have that REC1's value is equal to 1. Then it comes to the next line, which is REC2, which is equal to Fibo of n minus 2. Here n value was 2. Similarly, here n is 3, here n is 4. Okay, here the n value was 2. So now we do Fibonacci of 2 minus 2, which is Fibonacci of 0. So Fibonacci of 0, how would that look? So we are doing here this condition if n is 0, right? So if n is 0, we are going to return 0. So here we return 0. This becomes 0. REC becomes 1, REC becomes 0. And then we are doing calculation, which is REC1 plus REC2, that is 1 plus 0. And then we are returning 1 here. So this is calculated to 1, right? Now we come back to Fibo of 3 because this is returning. This is where we called this, right? So we come back here. Now we have REC of 1 equals what this returned, that is 1. Then we go to the next line, which is REC of 2, which is again equal to Fibonacci of n minus 2. Here n value is 3, 3 minus 2, that will be 1. Now we already know that Fibonacci of 1 value is returned as 1, so this becomes 1 again. Then we do the calculation REC1 plus REC2, which is 1 plus 1, which is equal to 2. Then we return 2 here, right? This amounts to 2. Okay. Now that we're done here, this is again the control is returned back to this calling function. Now that we know that Fibo of 3 is equal to 2, we go to the next line, which is recursive of 2, which is calling Fibo of n minus 2. Here n is 4, so 4 minus 2 will be 2. So now we know that Fibo of 2 equals to 1. Fibo of 2 from here we have calculated value is 1. Here we are returning 1. So this REC becomes 2, REC1 is 2, REC2 is 1. Then we do the calculation, which is REC1, that is 2, plus REC2, that is 1. Okay, then we return 3. So if n is equal to 4, our answer is 3. That means in the Fibonacci series, the fourth place in the Fibonacci series is equal to 3. So here, this is the 0th, 1st, 2nd, 3rd, and 4th. As you can see, the fourth place in Fibonacci series is equal to 3. I hope this is clear. If you guys have any doubts, please feel free to drop a comment. I will try to respond to everybody. Thank you everyone for watching. See you in the next one.